Today we're writing quadratics in standard form given the zeros. So we've done this in the previous chapters. We had to find a, but we were really writing them in intercept form or vertex form. So now if I know the zeros, we're going to write it into standard form. But first we need to talk about the number I. Let's remember that the number I is defined as the square root of -1. And for today, what we really need to look at is what is I squared. So if we look at the square root of -1 and we square that, we know that the square undoes the square root, so that would mean that this I squared equals -1. Now in future lessons we're going to use some more information, more powers of I, so we'll look at those a little bit now, but we're really only going to talk about this today and use the fact that I squared equals -1. But back to I cubed. If you would agree that I cubed is the same as I squared times I, because we add our exponents, and we said I squared equals -1, and -1 times I would be -I. And then I to the fourth power is I squared times I squared, because again you add your exponents, which would be -1 times -1, which equals a +1. And it's kind of cyclical around that I to the fourth power, and we'll look at that a little bit later in the week. But right now, what we need to remember, I squared equals -1. We never leave I squared in an equation because we want to take the equation from the imaginary to the real, and we do that by having I squared, and it equals -1. So what if we had an equation in standard form and the zeros are, say, 5 and -7? Well, we know that the zeros come out of the factors. The factors are x minus p and x minus q. So if it's x minus 5 and x minus -7, that becomes x plus 7. So we have x minus 5 times x minus 7. And you can multiply that out however you like. If it's FOIL, distributive property, vertical multiplication, I'm a little fan of the vertical multiplication here. This is set up just like you used to multiply numbers. So we have 7 times -5 is -35. Then we have 7 times x, which gives us plus 7x. And then, just like with regular multiplication, you moved down and you left a space, or you put a 0 there. Then we have x times the -5, -5x. And then lastly, we have x times x, which is x squared. And then where like terms are lined up nicely, this becomes really in handy when we're doing polynomials with lots of terms. So we have x squared, 7x minus 5x is positive 2x minus 35, and that's our final answer. So that's not too bad, but what if our zeros are imaginary? How about 4i and -4i? Our imaginary zeros always come in pairs. The quadratic must have real and rational coefficients. So how does the imaginary numbers come out of that? Well, when we're solving something like x squared equals -4, when we take that square root, we get plus or minus 2i. And it's always plus or minus, which is why our imaginaries always come in these pairs. And the same is true for our irrational answers. So again, if it's x minus p, our first factor is x minus 4i. And x minus q, that's x minus -4i. And then we can multiply that out. X minus 4i times x plus 4i. And I get -4i times 4i. So I get -4i times 4i, which is -16i squared. I times I is I squared. Then we have 4i times x. And so that's 4xi or 4ix. It doesn't really matter because multiplication is commutative. And then we are multiplying the x times the -4i. So we have -4xi. And then lastly, we have the x times the x, which is x squared. and we add up our like terms, our 4xi and negative 4xi very nicely cancel for us. Our I squared is equal to a negative 1. So instead of it being negative 16i squared, that's really negative 16 times a negative 1, and that is a positive 16, and then we have the x squared left. If you set that equal to 0 and solve it, you'll find that you get the zeros that we started with. Let's do one with some irrational roots, the square root of 7. Let's do a different one because I did that one in class. The square root of 10 and negative square root of 10. Those are our two zeros. So my factors are x minus p, so x minus square root of 10, and x minus q, x minus negative square root of 10. And again, we're going to multiply that out. Negative square root 10, x plus square root 10. Like I said, I like my vertical multiplication. You can FOIL it out if you want. We get square root 10 times square root 10. Remember, when we multiply square roots, we're multiplying the numbers underneath, and the negative outside stays negative. So negative square root of 100. And of course, there's a shortcut to that, but we won't do that in the notes. You can do that on your own. And the square root of 10 times x is going to give us x square root 10. And then we have x times the negative square root of 10. So negative x square root 10. And then we have x times x again, which is our x squared. And again, our middle terms, our irrational terms, cancel out. We have x squared from here. And then minus square root of 100 is 10. So minus 10. And that's our final answer. And then for the fun of it, let's do one that has a negative or irrational and imaginary together. So how about I square root 8 and negative I square root 8. So if these are our zeros, our factors are x minus square root I square root 8 and x plus, because minus the negative, I square root 8. And we can multiply that out. We get x minus I square root 8 times x plus I square root 8. Excuse my cough. I start with I times negative I, so that's negative right here, and then I'll multiply these. So we have negative I squared, square root of 8 times 8, right? These multiply together, 64. And then I square root 8 times x is x I square root 8. And x times negative I, x times negative I square root 8. So negative x I square root 8. And then x times x gives me x squared. And these babies cancel out because when I have the positive and negative the same thing, it's 0. My I squared is negative 1, so this becomes negative times a negative 1 times the square root of 64, which is 8. So this becomes x squared. Negative and a negative is positive. Positive 1 times 8 is 8. So x squared plus 8. And then the one other thing you'll need to know is the falling objects formula. 8. The falling objects formula we gave you before the break, but I'm sure you forgot, is h of t equals negative 16t squared plus h sub 0. Now, h of t is the height at any moment in time. H naught is the initial height. And that's height at time t, and t is time. So say we said we were going to drop a object from 200 feet. How long does it take to hit the ground? Well, our initial height here would be 200, so our formula becomes negative 16t squared plus 200. And what am I interested in equaling? Well, I want to know when it hits the ground, and we know it hits the ground. That's when h of t equals 0. So I'm set the equation equal to 0, and I can solve that. And we'll use our solving by algebra. Let's move some of this stuff up so I have some space. I have 0 equals negative 16t squared plus 200. And I can subtract 200. So we get negative 200 equals negative 16t squared. Then we can divide by negative 16. And I'm going to do this without a calculator here, so t squared is going to equal 200 over 16. I don't want to reduce it because I see a perfect square in the denominator, and that makes my life easier. So I'm going to square root plus or minus the square root. So t equals, let's see, this is 100 times 2. So the square root of 100 is 10, plus or minus 10 square root 2 over the square root of 16, which is 4, and that reduces to 5 square root 2 over 2. And I don't need to do plus or minus. If I think about what I'm talking about time, and seconds cannot be negative, so I'm only looking at the positive answer. And then you can put that in the calculator and get a decimal approximation.